So everybody, I just looked at my Pop OS machine, which I set to be checking for updates, operating system updates all night. And I checked in with it now, and the updates have failed because of some repository no longer has a release file. And it's in an infinite loop of making me ignore that. So I think I have to just kill the UI program. Like, these people just don't know how to make things. I don't know what else to say. I don't know what else to say. Okay. Is it 132? Okay. So this returns int, of course. Why not return something of undefined size? That's a great idea. Why is Emacs not indenting? Dude, everything is so broken. It's unbelievable. Okay. I had to reload the file because Emacs wouldn't indent correctly. Okay. Also, I said it in there, and it's got it in highlighted as if it were a keyword. Itten is not a keyword. I don't know. I okay. Okay, we don't want this. This is stupid. All right. Maybe because no matching if and def. No, because we were inside it. We were inside the code. That's what you do when you're in the middle. And it worked fine after I reloaded the file. Like it breaks all the time. Like Emacs C++ mode or whatever, it just fails all the time. State needed to be persistent because of the old physical terminals. I don't believe that. I used the old physical terminals. I know what they were like. I don't see that these things have anything to do with each other. I mean, this is literally just a software thing. As far as I can tell. But yeah, so like there's two errors, right? One error is that this is somehow global state that affects everything. Okay, that's crazy. But the second error is that if it's non-blocking, these function calls don't deal with them. Like I've written functions that read text over a non-blocking socket before. It's fine. You just do it. That doesn't even work. It just fails even when there's text waiting. So it's like if you're going to write a libc and you know that this is a thing, then make this work. Like they've had 50 years to do that. They've had more time than I have been alive to do that. I got a really good batch of oranges, so I am going to eat them so I have good programming energy. Okay. So I guess we'll test this some other time by somehow running a program that deliberately screws this up. In the meantime, we'll at least make sure it compiles. Okay. I need to add this variable because we haven't put this. Wait, why is this compiling? Why is this? I didn't add this variable. Oh, because it's if-def out. That's why. Duh. All right. TC debugger. We sure added a lot of lines of code lately. Oh, wait. Haha, I copied a file. Hold on. That's not a real count. Oh my God, that's so many lines. Wait, really? Did we go up 3,000 lines in like 2 days? Hold on. Type or bytecode builder, parser. What is this? Okay, this is a file. This is written by one of the tests. I don't know why it ended up in this folder. That's gonna annoy me. That's not a real file. Okay, I was gonna say I'm not liking those losses. But this is pretty much correct? Question mark. Still getting bigger than I would like. But still smaller than most compilers, so it is what it is. Mandarins is where it's at. Yeah, that's what these are. They're very good. I got an unusually good batch somehow. And we've got water heating up. Did I try 4Coder a long time ago? I didn't try the recent release that everyone wants me to try. I just know I'm not gonna like it. So okay. I want to do a very boring thing that's going to be kind of boring to watch. And that is this part. Where we correlate all of these. And then we'll reorder them since, remember that stream when I reordered them? We're going to undo that. Let's do the intrinsics. Let's paste all the intrinsics down. Boom. Boom, 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 boom. Boom, 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 boom. Boom, boom. Okay. Great. So good. It's almost like we're almost done. Wouldn't it be better if we had a programming language that would just generate these arrays? Wouldn't that be better? Also, I just don't have a caps lock key, so I always like hold shift the whole time. It is what it is. Your favorite error code is 11. Try again. The funny thing is, no matter how many times you try, it will never succeed. So why is it telling me to try again? Use preprocessor to generate code. You can't really do that with the C preprocessor. Back in the old days, when I was in college, I decided to switch to M4 because you could do more stuff, but you couldn't do that much more stuff with M4, and M4 actually sucks. So I switched back to C preprocessor. And just having that as a build step introduced all the complications of having a build step. Okay. Honestly, I don't think we need debug print register anymore. So I'm going to write down to remove it, but I'm not going to remove it yet because I want to get everything working. Debug print register was just a hack that only worked during compile time execution anyway, and now we have an actual debugger. I want to keep them lined up. It's weird how I can type almost as fast with my finger on the shift key. Very strange. Like, because I know my fingers are doing different things. I guess I just learned that. Okay, some people would not go do that because they felt like it was tedious, but you got to do that kind of thing. You know what I'm saying? Use the virtual keyboard to turn on caps lock. Too late. Didn't do it. Anything fun for the weekend? This is about the most fun that we could have. Oh, wait, here's what I have for the weekend. I have for the weekend a party-size bag of peanut butter M&Ms. Actually, I have two. So let's get the party started, is what I say. I do have Dyson Sphere Program. We might stream some Dyson Sphere Program today. Peanut butter M&Ms are really good. If I had a time machine, what would I do with it? I would go back and prevent myself from biting my cheek like I just did. Ow. Ow! Okay. We'll make sure this works. I don't think I did anything bad. We'll check it in. Then we'll reorder all the instructions. Or actually, first we'll delete... Actually, we could delete it before we check in. All right, let's run the tests. Bam, ba, bam, bam. How hard is making a game compared to writing a new language compiler? Well, it depends on the scope and ambition of the game. And it depends on the scope and ambition of the compiler, right? Both of those things. There's a tremendous difference between various versions of both those things that you could do. But a language of this level of seriousness is definitely easier than a game like The Witness. For sure. For sure. If only because, I mean, we had 12 people on The Witness at one point. With this, it's mostly me. I had a couple people helping out for a little bit, but, you know. Compiler may need to deal with error 11, yeah. That is true. I don't know how to count the number of people on the witness. The witness actually had 22 different people working on it at one point. But those were not all full-time people. It was a lot of like contractors and stuff, but or part-time contractors. This compiler, the most it's ever had working on it was 4 people. And that was only not for very long. How many programmers on the witness at once at peak? Probably 5, maybe 6. So if you count the couple of weeks that Casey helped, or he helped for more than a couple of weeks. He did 2 different batches of stuff. He probably did a good 6 weeks, 7 weeks of programming on the witness. But we also had an external programmer who was doing some porting, and then 3 in-house programmers, and then me. So it could be 6 programmers was the peak, but that's not 6 full-time, right? Like, I'm the only programmer who was working on the witness for its entire lifetime. Ignacio came on relatively early in 2009, so he was there for almost the whole development. He was there for development minus about the first 10 months. First 10 months, it was just me. Salvador and Andy came on at about the same time, a little after that, like 2010-ish. Oh my God. 2011, they've been at the company a long time. Wow. Like, we mostly staffed up on the witness from 2010 to 11. And that was about our core team of around 8 people total, 7 people for a while. Maybe it was like 6, 7 for a while. That was the team that made the game up until we went into full production, which was like around 2013, 14. That's when we started bringing architects on and audio people and all. That's when it gets bananas, right? A gay wedding is just like a straight wedding. That is correct. Correct. How much my motivation is financial gain? Approximately 0. It's not exactly 0, but it's very close to 0. All right. Let's get rid of this opcode here. Debug print register, gone. 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 Is that the output file? That's weird. Gone. All right. Great. And then we'll run the tests again. We'll run LLVMs this time. Was that always the case even for Braid? Yes. There was no reason, like, look, in order to be making Braid, keep in mind, I had to be making it before indie games was a profitable thing. Like back when I was working on Braid, the games that made money that small teams could make were like Facebook games and casual games on PC, right? Zynga didn't even exist yet. Zynga came later. All right. We got down under 5. Wait, what? That frickin' the test now is putting this file. We got to figure this out. Okay, I was hoping we would get under 56K, but we didn't. Who is making that file? I need to figure out what test is doing that. Okay. Some examples. Chess. So chess is running in the top level folder. How is it working then? If it's generating its exports in the wrong folder, it must be compiling using an old version of the file. So the test is not running properly. Yeah, this must have to do with the CWD change that I did. Yeah. All right. Let's test that again. Might fail. Yeah, there was some stuff that depended on what working directory you ran for the compiler from, and I didn't like that, so it CWDs when it starts compiling your program now. Which is good because it revealed this problem. This problem means that this program would work incorrectly based on where you were sitting when you ran the build, which sucks and is stupid. Let me go. Okay, so that's new. So it did go to the right place. All right. Commit. Comment bytecode flags, delete, bytecode print, debug print, stand-in protection for Linux. Blam. Okay. This is all good. Now I want to reorder these again because the ordering I put them in is not going to work. So let me just order them on this side and then I'll duplicate that. In the two other places it has to be duplicated because we're using C++. Okay, nop. Okay, we're going to put all the intrinsics together again. What a disaster. What a disaster. Okay, binops, respecialize, strings are equal. And I'm going to, like, this information about what is the contents should probably be in the other place now. Okay, where's respecialize? Part 2, that's going to, I'm just going to sort of just gradually coagulate. Where's respecialize part 1? There it is. So there, and fuck it, I'll just start deleting these. They're annoying me now. Okay, jump if 1 and jump if 2 all go together. Compare 1, compare 2 should probably go with the jumps. That's fine. Call procedure and return value. And return all go together. Segment load, segment store. Or sorry, load plus. So load store, assign index. Okay. This is starting to make more brain sense. I'm going to leave the offsets here and move them to the other place. Okay. Clear memory, duplicate array elements in it. These actually kind of go together, sort of. Intrinsics, we said we're putting down here. And in fact, atomics probably all go together. Array bounds check is going to go with cast bounds check. Mem copy is going to go near mem set. And mem comp. Oh, mem copy sized. And then regular mem copy. Actually, yeah, let's not put those together. Those actually go up here. Null pointer check goes with cast bounds check. Yeah, compiler books don't seem to... Yeah, they don't seem to value simplicity. They just want to seem to have things to tell you about, right? So... So part of the problem with SSA as well, like SSA is not very complicated if you understand what it is. But the way it's explained makes it way more makes it seem way more complicated. And you have to like reconstruct for yourself the actual meaning of it and what it actually does for you in order to understand. It's very annoying. A little trick with C macros would let you be able to have the bytecode instruction enum name next to the register flags. How would that look? What are the consequences? I mean, I'm potentially interested in doing that if there aren't bad consequences. Okay, all the atomics need to get together. Atomic add. Comp exchange 16B. CPU ID. See, these are all kind of bit operations. I don't know, prefetch is kind of down there. Can do it with X macros. Our technique for reliable maintenance of parallel lists. Oh, I see. But that's not going to work in this case. Data macro, macro. Oh, I see. Right. Okay. You make a 2-argument macro. Let's try it. Let's try it. The really annoying problem with this is it exposes all the things in the header, but I guess that's actually fine. And the stringified versions, so there's a stringified versions of the name, but we don't really need them to be that nice anymore. Where are they? Like these ones, like we cut the word bytecode off them, but we don't even have to do that. These are just sort of for assertions now. So yeah, we can just have those be the stringify operator. All right, let's give it a try. So we had to associate these anyway. Okay, hold on. Let me go. All right. All right, let's do the thing. So let's actually, we can lift our macro, right? So we could say, actually, let's leave the uninitialized in the enum maybe? I don't know. Okay. Define x of y to be nothing for now, right? And then we need to do we need to define x of a bunch of the, we need to do this over and over, right? We need to define something, right? Wait, how do I do? Do I want to just put this in a header and include it multiple times? Would that be better? Then I don't have to deal with macro backslash. So I could, I'm going to do that. I'm going to say these are going to go into these are going to be in bytecode instructions.h, and we're going to say define I of x to be x comma, right? And then include bytecode instructions.h, right? And then oops. Okay. All right. So then we can go to our stringified version and say define I of x to be, is it single hash? Wait, how do I do this? How do I stringify on the x as opposed to stringifying x? Right? Is that going to do the wrong thing? Whoops. Like, you know what I mean? Like, why is that not going to just stringify the character x? Or does argument substitution happen first? Okay. So we're going to do this. Undef I. Except we're going to have to make it x comma y in a minute. But that's okay. We can just make sure that this... Oh, it won't work yet because I don't want to break the debugger. Too many initializers. Really? Oh, eh. I will put it here. Why does it say too many initializers? Yeah. I'm just not sure because we didn't put the array dimension here, so I'm not sure why it thinks it knows. Oh, because I have an extern, don't I? I have an extern. Yeah. It's fine. This is probably good hygiene to have this. Okay. Great. So we have a header file. We have this. We have that. Oh, you know what we're doing? We're also making gains here. We're going to drop below 56K when we make our next gain, which is this. All right. Emacs is screwing with my indentation. Thanks, Emacs. This is going to be, oh, geez. These are out of order, of course. Oh my God, Emacs, what are you doing to me? Load plus offset is AR. Segment load plus offset is R. Segment store is comma lowercase r. Let me start deleting these as I do them. I can verify. It'll be easier to find other things. Load plus offset, store plus offset. A capital R. Oh, see, I already messed up. Store plus offset is A lowercase r. Assigned a big constant. These are all comma cap r. Assigned a string literal. Assigned a function pointer. Lee we already got. Call procedures is 0. Index type table is underscore r. Is underscore a. Cast bounds check is AR. Array bounds check is AR. Okay. These are all bam, bam, bam. I'm kind of doing these in very random order. RD-rand, RD seed, read GSQ word, xget BV, byte swap, pop count, bit scan. Atomic increment. Good thing I spent all this time doing this so I could delete it all. Prefetch 0 RDTSC and SCP containment program protocol. All right. Oh, wait, atomic add, not an and. Why is atomic add? Oh, because it returns the old. I don't know. I understand why that's different from the other ones. whatever. Okay, bitwise and so these are all ABR. Bam. So are memset and memcomp and chew people. Boy, sometimes we just gotta sneeze. That means I'm not drinking enough hot tea. I hope I'm not getting sick. That would be weird. I hardly been outside. I could actually get rid of the underscores here and everything if I wanted to. We could do that later. I could actually put the reads and writes into two separate columns, which might even be better. Let's just get the information across. Exchange and CPU ID. Comp Exchange 16B has the monster one. Stack area, struct dereference, and or. Compare to, and add extend and subtract extender all ABR, and says memcopy. Memcopy sized. This is AR 0. Cast number to number. These three. Okay. Poke return value is AR, which is also compare 1 and jump if 2. Getting toward the end. We did our DTSC and P. Jump F1 is underscore R. Init stack is 0. Clear memory size is R. Array elements is R. Everything else is 0. So now let's actually scan also, because I believe if we don't give enough arguments, it'll actually accept that for some reason, because C++. So jump, return. Maybe it'll warn now. mfence. Jump, return mfence. Debug break, pause. Clear memory size, we got duplicate, we got no op and uninitialized. All right. Now we need to go to the other ones. All right, and then okay. And we could put this right next to this. Not enough arguments. Oh, did I not save the file? I didn't save the file. Syntax error constant. Oh, here's the fun part, everybody. Oh, I didn't put a comma. Goofs. I think I want to break it into reads and writes then. I'm going to re-up my tea now. Thanks for the suggestion. That was helpful, clearly, I hope. I mean, just look at the gains, guys. I have to fix at least 4 comments. Yeah, I'm going to do a pass over the comments in a minute. We're just verifying that nothing broke. Some of the comments are irrelevant. Yeah, we have the parenthesis replace. Some of them have, you know, these flags that we want to get rid of. I don't want them to be messy like this. I want them to be like at a fixed position. I don't have column display turned on. Whatever. All right. So that's pretty good. So yeah, I think we're going to make it a 3-banger, but first we're going to check this in. Wait, what just happened? First we're going to check this in because this has been successful. So now I want to go I want to make it 3 columns. And then we'll make the formatting nicer. Okay. Now I'm going to do that. AB not declared. Easy, easy. I still have a because. No, that's it. That's an actual parenthesis. Sometimes I use parentheses. That, however, was not. Okay. Okay, good. Now, oh, hello, rating 2,089 million people. What is going on? Why are you rating me at a mere 12:15 p.m. on a Sunday? Isn't this like prime work hour? What is happening? What is happening? Oh, yeah, good point. These parentheses are all not correct. All right, so now we have these and this works. I'm tempted to check in, but I'm not going to be a wuss. Actually, let's be a wuss and check in. Because then we can go even further. All right. That's what we're all about on this stream, is taking it further. Let's test first. It is 9 p.m. in non-freedom countries. Well, not where the Raiders live. Well, I hope you had a good work day, work Sunday. I had a good work yesterday. Did some major things. All right. So now that we have this, here we're actually going to define _r to be read r. Okay. And we're going to get rid of these. And we're going to do this. Okay. That's our next step in our transformation from caterpillar to butterfly. We're going to be a beautiful butterfly. It's a mandatory Sunday break in non-freedom countries. I know, dude. If you try to walk around on Sunday in Brazil, oh my gosh. I've done that. What happened to the debugger? The debugger works great. We finished it, I mean, for now, yesterday. Is it actually illegal to work on a Sunday in Brazil? I wouldn't be that surprised. Okay, we should actually test the debugger. Shouldn't we? Oh yeah, let's we rigged this to crash intentionally, so let's not do that anymore. Let's just do this. So it knows that we wrote v6 in this case because that's why it printed this. It's like, hey, v6 got 3. Now v6 has 3. v7 got 9. Okay, it's great. Time and a half for double pay on Sundays? Dude, I would be working every Sunday. As a compiler book I was working on the other day, something I intend to be for people new to compiler development. Probably mostly, like, I'm not sure if it's the best first book on compilers. We need to figure that out. But it's definitely for people who haven't actually written one before. Yeah. Right now it always does a step. We could make it repeat the last command later, but right now it always does a step. Okay. So this is all good. This is very nice. So now I could get rid of the underscores by doing the following. Right? Something like that. Okay. Right? No, it's a disaster. Oh, because 0. I forgot about that. I had in my head, oh, when I do this, I'm going to need to define 0. But I didn't do it. Then there was some other problem. What's the other problem? Underscore underscore R. I left an underscore. Oh, because of one of the ors, one of the big ors. Yeah. All right. So that's probably not defined. RO. Why doesn't that work? Oh, because I didn't put the underscore here. Duh. Duh. Okay. Then we can replace comma capital R with comma lowercase r. Or do we want to go all uppercase and go like capitals? I think in this file, it actually helps if they're lowercase. The reason is because the constants are all frickin' uppercase, right? Oh, you know what? We could put bytecode on here. Here, let's do this while we're having fun. We could put bytecode on the actual enum. So all right. And then in this macro, we go there. Now you're thinking with portals. I'm glad you like the stream. The VOD of the debugger programming is on Twitch. I did a highlight of the 3 hours. We did more after that 3 hours, but it was a pretty good 3 hours. Okay. Now what? I mean, this is pretty good. We could just, oh, actually, we have a bunch of things we don't need here, right? We don't need capital R. Oh, I literally had that right above the place where I typed it. Okay, good job. Good job. Okay, AR, ABR. By the way, these are all illegal. You're not allowed to have identifiers starting with an underscore, according to Bjarne Superstrup. Actually, that might be a C rule. We don't use ABRO, right? Oh, we do. Lol. We use RO. We don't use ABR. We do use AR. We do use AB. We don't use O. All right. Barney Star Soup. If you use an identifier like underscore foo, your program is ill-formed and undefined behavior will destroy your program. I mean, technically, yes. Technically, they are allowed to launch the nukes because I put underscores. Let's make that a little bit less fragile. How's this for making sure things are good? Read A left shift num reads bits is equal to write A. In the macro, we shift the read flags to turn them into write flags if they are in the third column. Look at that. Instead of some undocumented random shit that somebody 10 years from now has to figure out why it broke, we're actually telling them and asserting if it's wrong. It is not UB underscore reserved for internal use. Right, but if you use something that is reserved for internal use, what is that? I mean, I guess it's not UB. I guess it's like, I don't know. I don't know, man. I'm sure they could find some excuse to make it UB so they can break your program. Now, the only reason I was using underscore was to make it easy to type. But there's no reason to do that now that it's a macro anyway. So we can unlaunch the nukes. Everything still works. All right. Let's just to have fun. We've run the game from inside the compiler, but we haven't done Heroes 1.1 inside the compiler, which has good graphics. I want to see what frame rate we get there. So this is going to take a minute loading. We might have slowed down compile time execution a little bit yesterday by adding all that logic. I hope not, but we might have. It doesn't seem that much slower. Like this was slow yesterday too. I'm also busy on another game that I'm not showing yet. Actually, that's not correct. There was a third game that we're not showing, but it's on hold. So the two games right now are this and then the Braid Anniversary Edition. All right, I'm going to move around and like load some animations. To get all the stalls out of the way. Like that's loading a push animation. It's probably loading sound effects and stuff. All right. So I can actually run around now without stalls. So let's go to Heroes 1.1. Now it's 26. No, it was about 18 FPS right there. And on this level, it's about 3.7 FPS. Oh no, say all the trolls. Oh my god, your game only runs at 3 FPS. What's your problem? And to them I say, let me see how fast your game runs inside your C++ compiler. Or your Rust compiler, for that matter. This actually isn't... This is the debug build of the game, but it's not the debug build of the compiler. That would be pretty slow. But it's the debug build of the game running inside the compiler. But like release build of the game wouldn't be that much faster. It would be faster because we wouldn't have array bounds checks and stuff. And release build optimizations right now all happen in LLVM. So we wouldn't, running inside the compiler, release build would not give us more optimizations. Is it bytecode interpreted inside the compiler? Yes, it is. What does it mean to run in the compiler? So we have a compile time execution model that lets you run arbitrary code. And by arbitrary code, we mean anything that you can compile to a finished program, you can also run at compile time, including rendering graphics and whatever, and playing your whole 3D game and stuff. I think we're loading bitmaps from the next screen. This might take a while. Let's see. Okay. Anyway, we're not gonna wait while this is probably like processing some meshes or something. Like the first time we go into a level, if we haven't played it since the artist modified the level and or whatever textures are on there, we like process the meshes and compress the textures, which I still haven't sped up, but I want to do that maybe later tonight. I don't know. I'm gonna write that down. Maybe today is the day that we change the way texture compression goes. Question mark. Okay. I feel really good about the compiler. I've got a bunch of notes about test coverage and small things to fix, but yeah, I'll do those later. So like, do I want to format these in some way? Maybe. Maybe it just makes things harder to read. Maybe it makes them easier. See, if I do this, Emacs is going to hose my indentation. So I have to leave this one over there because Emacs. Now, by the time we get down here, these aren't going to fit, but whatever. Look how nice these are. Look how nice. Okay. Jump. You might as well jump. Doot, doot, doot. Doot, 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 doot. How many spaces do we have up here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Great. Good. Bam. 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 Okay, these instructions are fatties. They stick out. It's fine. Or we can just go add some more spaces in a minute if we don't like that in the final estimation. Okay. I think we need another column or two. Let's do the following thing before we finish here. Let's replace comma 1, 2, comma with 3 spaces, just, no, 2 spaces, 3 spaces just to be safe, with comma 1, 2, 3, 1, 2, 3, 4. All right. So we didn't get extra spacing on a couple of them. Oh, I also did it too late. Like the ones that didn't have 3 spaces after the comma, but I didn't want to actually replace the other comma. So there we go. Now we get a straight line straight down. It's great. It's great. Look at that. No! All right, well, we got one more. There we go. There we go. Look at that. Oh, how nice. Okay, now we need the comments. Now I guess we're doing 2 spaces. No, we'll go back to our 5. Great. Hope it works. Now we're on an auto formatter. Does your macro suggestion put you on the future beta list? Sure, just send an email and I'll put you on there. But you have to prove it's you somehow. Like you have to whisper me. You have to whisper me on Twitch what your email address is going to be so that I know it's not someone claiming to be you. You know what I mean? All right. Testing. Testing. And then we'll check that in. That's great. I'm feeling good about these things. Doesn't the AR column shift left one at RDTSC? Let's see. Maybe it does. Oh, it does. Oh, no. Oh, no. All right. There we go. All right. Oh, this one. Where's RDTSC? There we go. There we go. Now Go format shows up and wrecks my program. Integer divide. We got it. We got it taken care of. It's all good. Okay. So we're going to commit that. Rearrange bytecode instruction information. That's great. We got gains out of having fewer tables. We still have significant code due to the added debugger and things that we've been doing lately, but it is very, so we were at like 553 something. So in 600 lines of code extra, probably a little more because we got gains, but we have a debugger and all sorts of good stuff that we didn't have. I think BC debugger by itself is just a couple hundred. Let's see. 341. Yeah. And then there's more, there's code in bytecode runner to handle this. And then really there's other things that I've been doing. Do you believe MSVC with UO to date? I don't know what that means. Up to date? What is up to date? What is up to date? Okay. Tea is good. Guys. So do I want to keep programming? So I could keep programming, or I could take a break, read a little bit, write notes for my book a little bit, and then start a stream where I play Dyson Sphere Project, which sounds kind of appealing right now. I don't know. When Visual Studio writes up to date, do you trust it? No. No. If you modify a file while it is compiling, but after it has, or no. Basically, if you modify a file while it's compiling, it'll mark it as up to date at the end, and then it won't rebuild with the changes. So like if it's already read a CPP file or a header file, like, but it's still compiling, which since it takes so long to compile is very easy to do. You just modify the file and then it's messed up. It happens to me more often than I would like. Did I ever have a hard time searching because of alignment? I don't think so. What am I reading? I'm finishing rereading Star Maker by Olaf Stapledon. And then I don't know. I'll probably try to finish Dream Machine, which I still haven't finished. Still way in the middle of. Isn't the Dyson thing like a bootleg Factorio? No, it's different from Factorio. I'll explain SSA. Read my book. May you ask what the compiler book was? I started writing a compiler book on stream, and I believe the VOD is still up, so you could check it out. It was mostly just me typing notes boringly. Have I read Moby Dick? I have not. It was on the list. So many books are on the list. Oh, so many. Oh, so many. Okay. What mic is this? I don't remember. It's one that Casey sent me because he liked it. Compiler book sounds fun. Am I going to sell it or give it away? I'll probably sell it because it'll probably be nicely printed. And, you know, if you don't want to pay very much for it, you can buy it used. Used books are pretty cheap, unless it's a college textbook, which this one will not be. How much does the Dragon book cost? Let me go on Amazon. Dragon book is ridiculous. Dragon book. Okay, this is not... $76 to rent, $154.66 to buy. What a scam. This is such a bad book. It costs $150. Oh, first edition hardcover, $210. This is the edition we had when I was in school. Now they have this shitty 3D graphics. This is like what it used to look like. See, it actually used to have important things on the cover like data flow analysis, which actually there's not that much about in the book. But the new cover, by the way, in addition to being awful visually, it has syntax-directed translation slaying the complexity of compiler design, which is stupid because parsing is easy. Syntax-directed translation is a fancy name for them trying way too hard to do parsing. Like, it's just everything about it is so bad. Some people still say Zoma God Dragon Book. Those people do not know how to make compilers. Anyone who says Dragon Book is good does not know how to make compilers. What's the purpose of my book? I'm just trying to write a good book about how to make compilers that will do well in the modern day. Dragon Book is great for historical reference on how they built compilers. No, it isn't. It's not even good for that. Because again, it spends all its time on parsing. If you don't make software more complex, how will you increase your hours? I don't know. Is there a better book that already exists today? There's a number of books that are better. So Engineering a Compiler is better. Andrew Appel's book is better. Crafting Interpreters is probably better. Like, all these things are just better. You shouldn't read the Dragon Book, period. It's a waste of time. I mean, okay. It's okay as a reference. Like, if you're not trying to use it to tell you how to make a compiler, if you're instead trying to use it as like, oh, here's a book that writes about some different things that I can flip to a particular page and follow the reference or whatever, then it's fine to have Dragon Book on your shelf, but do not learn from it in terms of how to build a compiler. It's not good. What you've had real trouble finding material on is how to build that AST and then what to do with it. I mean, the dirty secret of AST is you can't do very much with it. The secret of AST is it's a sort of, and I'm trying to figure out what to write about this for my book. It's almost a vestigial step. Like, the reason you convert to AST is so that you could convert to bytecode. And it's sort of, because it's easy to write code that navigates a tree, it's sort of good for that reason. Like, it's sort of good for type checking. But if I were given the assignment to rewrite my compiler to do type checking on something besides an AST, I suspect I could do it. And it might be cleaner. I don't know. I need to think about it. But you can't like do useful manipulations on the AST with a modern programming language. It just doesn't work. So don't really bother. Will it be a printed book? I would like it to be a nicely printed book. Game Engine Architecture 3rd edition is $100 and it's thick and new. It is $155 because it is the college compiler textbook that every college compiler class requires that you buy. And many computer science degree programs have compilers as a mandatory class. That's why it's $150. Will the paper copy of the book have an SD card or something accompanying it? I doubt it. We might make a website with sample programs on that you could go to and get them. I don't know why we would put an SD card. Used modern compiler implementation. Do I know that book? Let's see. Oh, that's Andrew Appel's book, right? Yeah. This one's okay. It's the problem with it is very slanted toward implementing a compiler in a functional language. So like he has like a C I forget, he did all the implementations twice, once in ML and once in like, I forget if it's Python or C or something, right? But the problem is the non-ML implementations are not idiomatic in the other language. So it's like, I'm not sure exactly what the point is. Oh, there's 3. There's C and Java. Yeah, I mean, those are kind of lower quality than if they were targeted for C or Java, right? And honestly, his viewpoint on things is a very functional language viewpoint, which is fine. It's just, you're not going to learn how to make a fast compiler from Andrew Appel. Let's put it that way. But it's an interesting, different viewpoint on how to do things. Can I expand a bit more on what they do in the Dragon Book? It's a 1,000-page book. It spends 371 pages on parsing, making parsing super complicated and a great deal of work, when in reality, parsing is trivial. And the things they do for parsing don't even help you have a quality user experience, which is what you would care about by putting a lot of effort into parsing. And then they have 10 pages on type checking. I shit you not. 371 pages on parsing, 10 pages on type checking. And then they go on, and the rest of the book is kind of like sort of ticking off boxes for the rest of the compiler. Like, it's just not good. They write a ton of classes. Well, they say no. So first, you should use a lexical analyzer generator to do your lexical analysis, and it should use regular expressions, and you should write all your base token descriptors as regular expressions, which is garbage. And then they say, oh, and then you should use an LALR parser generator for your parser and whatever. And they go super far into the rat hole that all these compiler classes do about LL versus LR and all these things that don't matter and nobody cares about. And certainly don't matter in terms of practical implementation. Like it goes on forever, and it digs deeper and deeper holes about these things. And it makes it sound like it's an open problem in computer science how to parse things well, when in reality, it is not. Do I feel like these books that provide bad advice are actually a way of locking people out on purpose? No, I don't think so. I think something like the Dragon book comes legitimately, like I think the authors probably never had built production compilers. I don't actually know anything about the authors, but they probably never really built production compilers, or if they did, they were probably very simple compilers that didn't do much past, past parsing. Like they were probably transpilers or something. And they don't have, so the number one, the modern programmer and especially modern teacher, one of their number one personality traits in order to keep software from turning into crap needs to be an allergy for complexity or a distaste of complexity. And Dragon Book does not have that. They'll just get incredibly complicated about things that are simple. And they have no aesthetic about how complicated a particular task should be, right? They just go into it like forever. The video where me and Casey talked about parsing really helped. Do I think I could make something like that for type checking? Maybe. Like, maybe it'll just be in the book. Like, I don't know if Casey wants to talk about type checking. If he does, I would be down to do another one of those. But I sort of just want to do it in the book, maybe. You feel like a lot of people think they have an aversion to complexity. What they really have is an aversion to not adding more complexity to hide the other complexity. Yeah, I mean, I am still learning personally as a programmer how to make things simpler. Definitely on this compiler that I am making, I've had a lot of times where the first version of a system was complicated and driving me nuts, but I didn't know how to simplify it. And then I came back later and figured out how to simplify it. That is definitely a thing. So it's not like I magically know how to make things simpler, but the difference is it bothers me when I don't know how to make it simpler. And because it bothers me, I keep thinking about it, and then I figure it out later and I come back and manage to make it simpler. I think a lot of people just don't do that second part. Any thoughts on how non-university software engineering degrees have become more about business and project management? I don't know anything about that world. Do you mean like 2-year college kind of degrees? I don't know what's going on there. What are the techniques for parsing instead of using regular expressions? You just write the parser. If you go on YouTube, let's find the thing that somebody was just talking about. If I go to my channel on YouTube, there is I know I have a video with me and Casey talking about parsing. Isn't there? Parsing. Parse. Oh, this was right. So it doesn't have Casey on it visually because this was just, was that 10 months ago?
So I guess while I'm collecting questions,
Yeah.
these questions
Wow.
was one that
I'm a
pretty
youngster. Look at that.
straightforward one to answer, I would suspect. So I'll go ahead and ask it. You can be answering it while I look at the other questions. And that is, any plans to make OS-independent static or dynamic libraries? And I guess I don't know exactly what they mean by that, but I'm assuming that they mean something like...
It's really annoying to try to get programs that run consistently on different browsers. Oh, this is the Q&A, right? That's the Q&A. Hold on. I was like, wait, that's not about parsing. There we go. Something like using... Wow, this has 50,000 views. That's pretty good.
If you want to, John, and tell me if you would rather not do this, but I actually have sort of a introduction to this that I thought about because I kind of know exactly what it is that I wanted to ask you about first, and I think I can give a quick explanation of why I wanted to ask you that. So if you don't mind jumping right into that.
Yeah, that would be great.
If you had something in mind you wanted to go over first, we could do that instead, for sure.
No, that's good. So somebody on stream suggested me popping a screen share so you'd have a lower latency. And
why can I not hear John all of a sudden? Hello?
Hello. It's back when I had my other microphone.
So I cannot hear John now.
Okay, so the reason you couldn't hear me is somebody suggested that I do screen share on Discord. So I popped open a screen share, and then that started streaming video to you, and instantly your voice quality dropped a little bit, and I guess it stopped sending audio from me as well. So you can't even have a low latency screen share. That's just,
I don't know what
it is what it is. Yeah, no, it's all garbage. Okay, anyway, so yes, let's start the way that you suggest. I heard everything you said, and my stream heard everything you said. So anyway, what we end up, it's a pretty long discussion. Or what I realized very early on was like, look, okay, if instead of using Lex, like, okay, I've been using C for a year or two now. I see how to program all this stuff. Lex makes you write little snippets of C that you put in there anyway, but it would be just simpler if I just emitted the tokens and then just only used Yak to do the grammar stuff. And so I did that first, right? Anyway, so we go through, we sort of talk about how the Dragon Book approach tells you to do things, and then what I started doing instead, and then what I do today, and it was pretty good. It was a good time. Do I watch my diet? Not as much as I should. I'm kind of chubby. Do I have plans for a more financially independent compiler development in the future? I don't know. I mean, if there are ways for the compiler to make money, that would be interesting because then we can hire people to work on it in a high quality way, which I would like. The question is, how do we do that? And I don't know the answer. I don't know. Do I know how Sean's C compiler is coming along? I do not know. You would have to ask Sean. I'm not into C. I don't want to use C anymore. So, I'm not really, it's not like I'm waiting for people to make a C compiler. Just have ads in the compiler. We could do that. Oh, that would be funny. Premium price for businesses and free personal use. I mean, maybe. I could see doing something like where we license a better code generator for businesses or something. I don't know. Can I talk a little bit about how I do type checking inference in the compiler? I don't know what, it's a pretty broad topic, so I don't know what to say offhand. Yes, it's true I don't use Hindley Milner. I think that's a silly thing. I don't understand why, whatever. I don't understand. Weissman diet ads. Okay, I think we're going to raid somebody else. I'm going to take a break, and then we'll come back later and do some gaming because it's Sunday. Although, who knows? You never know. We might change our mind. I didn't realize how many views these videos are getting. It's pretty good. 100K on the 3D video games doing graphics. That's not bad. Parser 150K. A lot of people want to know about programming language parsers. I wouldn't have expected that. Why are 50K people watching that video? That seems like a lot. All right, let's figure out who to raid. We've got to pass on. If we have any more Lana viewers, we got to pass them on. Wow, 748 viewers. Why am I quitting? Why don't I keep programming with all these viewers? I almost want to keep programming if we have 748 people. Let's keep going. Why not? Why not? Okay. We probably lost some people because it looked like I was signing off, but what do we do now? I have a bunch of notes about things to fix. We did the code block parent pointer thing yesterday. That was good. Bytecode runner uses basic blocks. It does that now. That's done. Honey Badger. That's frustrating LLVM stuff. We could do frustrating LLVM stuff if there's anybody on chat that knows about LLVM. So I was in the middle of converting some old code that does debug information in a, like the way that we feed debug information to LLVM is just like a massive maze of annoyance. So it starts here on line 332 and it goes till I'm not going to count this because this is stuff that we would do no matter what. I think we have an ends here. Or I thought I did. Wait, where does it start? It starts at 332. Okay. And goes till about 571. So it's 240 lines. And the goal of that 240 lines is just to call set current debug location at the right time with the right argument. And that's crazy to me. So I'm trying to figure that out. But part of what was, and that's after I managed to factor it together. Like it was actually worse structurally. Like update debug info used to be in a couple of pieces that were spread through and stuff. Okay, so what I finally managed to get this. So when we are outputting code to LLVM, we need to make basic blocks because LLVM wants basic blocks. And the old code didn't have basic blocks to work with because we didn't have basic blocks in the front end, which we do now. Although now our basic blocks are a different idea than LLVM's basic blocks a little bit. But nevertheless, what the old code was doing was saying, hey, if an instruction is a branch target, or if it's one of these, we create a basic block, right? If the previous instruction is one of these, or the current instruction is a branch target, I think it was. Now, I took out the branch target flag. Now, oh, I should actually check if we use that. We do in the x64 backend, I guess. Anyway, the problem I have is the following. We still have this array of blocks, of LLVM basic blocks, one pointer per instruction, which sucks. Okay. I mean, okay, in the grand scheme of things, it's not that bad. Like, there's 400,000 bytecode instructions in the Sokoban games. That's 3 megabytes of this array, but it's dumb. We shouldn't, it's a gross way to do it. So I'm trying to rewrite it. And in principle, it should be fine. In principle, we create one instruction per basic block, which now we have this array, basic blocks per one of our basic blocks, which is a much smaller array, right? Each basic block might be 10 or 20 or 50 instructions. So this is going to be a much smaller array. Now, the problem is our basic blocks don't contain, they don't split on exits. They only split on entries. So these are all the instructions that can cause exits, or have internal basic blocks and stuff. Okay, so I need to go to a system where we can create blocks. Okay, so first of all, we do all this in a prepass, right? And that's annoying. We want to do it as we unroll the code out. So maybe that's step one. And then step two is to not have this array. So we could just create a basic block when we do when we do this, or when one of these instructions is being generated. Like what we would like to do. So like if we're doing, let me show you one of these. Like an array bounds check. This decomposes into a few operations in LLVM, and that involves creating some basic blocks, right? And then you need to make a basic block that we branch to at the end. And right now we say, oh, it's this pre-existing thing in this blocks array. We want to get rid of this blocks array and just say, make a block here and branch to it. And then we'll set that block as the current block, right? And then the outer loop can pick it up and run with it. And then we don't need to have this big annoying array, and we won't have this fragility. Like right now, there has to be this knowledge coordination where this switch statement knows about what the individual statements are doing, and we can get rid of that, and the individual statements can just register an outer block. Is there a reason not to just set debug loc before outputting each bytecode instruction? There is a little bit. So there's an additional problem that I didn't know about. So, and I came to understand it better a little bit from reading the source code and stuff. The additional problem is the following. You cannot create an empty basic block in LLVM, as far as I know. It's not allowed because every basic block has to have a terminating statement. So if like bytecode array bounds check makes a basic block at the end that's like, here's what I'm going to branch to, that block is not allowed to have 0 instructions. If we create another block afterward, the empty block has to jump to the new block, or we have to reuse the old block or whatever. Like something like that has to happen. And I didn't do that correctly before. And when you don't do that, you're in LLVM hell. It is very bad about telling you what is wrong. That Josh wrote, there are some like pass checking things, but like even those kind of suck. I guess if we know that the problem is there isn't a terminator, we can check for that. It's horrible, dude. When you do something wrong in LLVM, you're on your own kind of. So, we need to avoid that. So I think my first goal is going to be to take this stuff and put it in our main loop now. And that'll make our main loop more ugly, but then we'll get rid of the stuff and maybe that'll make the main loop less ugly. You can create empty block during flight, but at the end it is not allowed. Yes, exactly. Structural dead code is not allowed. Interesting. So I didn't know that. I assumed that making empty blocks was going to be fine and that you could just fall through to the next block. And that is totally not how it works. Which I guess makes sense. Like, I think LLVM wants to be able to just reorder the blocks however it wants without doing further analysis. So, if every block has to have a terminating statement that goes to another block or returns, then you just know you could do that with impunity, right? It makes sense. Our basic blocks in our front end are not like that. I don't know if we're going to want to make them like that eventually or not. We'll see. But now that I have a more refined model of what LLVM wants, I can take a second crack at this problem. Oh God, someone's linking the Doxygen. Yeah, this is what LLVM's helpful documentation looks like, by the way. It's horrible. It's the worst thing in the universe. Detailed description. Oh, I didn't actually see this part before. A well-formed basic block is formed of a list of non-terminating instructions followed by a single terminator. Terminator instructions may not occur in the middle and must terminate the blocks. The basic block class allows malformed basic blocks to occur because it may be useful at the intermediate stage. However, the verifier will ensure the blocks are well formed. Okay, that's actually useful. This is actual documentation, this part, which is amazing. The rest of this is not documentation, but that actually is documentation. It's astonishing that somebody made some actual documentation. Yeah, exactly. 1% of the page is useful. Just imagine how good LLVM would be if they just deleted all the auto docs and wrote an equivalent amount of this. How good would it be? It would be frickin' amazing. Tea is still boiling. Writing good documentation is also hard and time consuming. It's easier than writing a good program. Are you kidding? And it's one of these things that gets easier the more you do it. So if you don't ever do it, of course it's hard. Okay. Tea is almost boiled. Now, so we're going to try and do this. This could be a disaster, but we're going to try and combine these two loops. Actually, let's check to see if anyone needs to use... See, there's multiple things called block. I don't understand why... I don't understand why we branch to block 0. This one is weird. Okay, so this is preventing me from combining the loops because this is happening before we generate any instructions. Why would our first output instruction be to jump to the first basic block? How does that make any sense? That, like, this comment is a unhelpful, helpful comment. First block can't have branches to it. Well, this is making maybe. This is always adding as the first instruction a jump to the. Why is that not an infinite loop? I don't even understand. Okay, what is the, okay, set insert point and, oh, okay. Entry block is actually before block sub 0. I don't think, let's try to clean that up. That sounds bad. That sounds very bad. So entry block, I think we generate before, okay, I see. So this is really block sub 0, and these are like later blocks. But we can do this at the end, actually. So this isn't preventing us. We can do this at the very end. Let's try it. So here we set insert point. Right? We make an alloc A, alloca. We I mean, we probably need to do this stuff before generating. I didn't write this code originally, so I'm not sure. But this part, okay, let's just do this part at the end. So, let's get another set current debug location. Okay, so we're going to jump from the entry block to our first block. I feel like that should work. I feel in my heart like that should work. Don't you think? All right. Oh, not x64, LLVM. Nope. It didn't work, guys. And now we get a useless assertion from LLVM. Oh, I didn't set insert point here. I actually don't think we need this one. And I don't actually think we need this either. Come on, finish. Thank you. All right. That's great. First block can't have jumps to it, also must contain all non-dynamic alokas like variables on the stack. You can have alokas in other block, but LLVM doesn't like them much. I see. Does not like them much mean that it messes with optimizations? All right. Let's try the game with an LLVM. Sounds good to me. Okay. We could check that in, but we're not going to do it. So we don't even need entry block here. Okay. All right, one more quick test since I moved some stuff around. And again, this is code that I didn't write, and it has some fragile things about it. So I'm being careful. Wait, why did I run x64 tests? Did I just do that, or was that... All right, well, it's working. Okay. So now the goal is put these blocks together. This is the hard part. Let's commit, just so we have a place to go back to. Start rearranging LLVM backend main loop. All right, great. So we got this loop. We've got this loop. This loop. This is the one that actually converts the instructions. This is the pre-pass. And so we want to get rid of the pre-pass. So for every of our basic blocks, we're going to say, and we're going to rename this first instruction in our basic block. That's true. Okay. And then, okay. We're going to have a create block, which starts as, oh, actually, let's put this in here. We're going to have a create block. We're going to have an instruction. Oh, we already have an instruction index. That's great. Let's put in the same order. Whoops. Emacs is getting slow on me. we're going to put, this is our basic block name for debugging purposes for when we create them. Okay, now previous is whatever was our previous instruction, right? Basic block creation stuff. Okay. Look how slow that was. I just slammed that out and LV or Emacs was like, oh. I can't believe how slow. Emacs, they make it slower every release. I don't understand how. Actually, I do understand how. Basic block creation stuff. Return, jump, jump if one, jump if two, etc. We set create block. Previous equals BC. Okay, if create block, we set this blocks array. If it's the first instruction here, then we do this thing. I think we actually I don't remember why it is that we don't create empty basic blocks here. That because I know that we have empty basic blocks in the front end. Anyway, so then we need BB index plus plus, which I'll put here. And then there's all these things which we could move later, these declarations that we're using that are out here. So we have blocks, we have our new array. Okay. And then down here is our regular loop. Have I done any optimization on the mispredicted branches? No. We don't really have optimizations yet. We are still relying on LLVM to do optimizations. The mem to reg pass or similar looks only at the first block. There's some mechanism that makes Aloka special. Puts way too many check stack all over the place. Great. We like checking the stack. We love checking the stack. All right. Well, that we just crashed. We just crashed. I probably didn't initialize something, or someone's reading from the blocks array before we write to it, or oh, guys, we can't just do that. Okay, here's the problem with this plan. So I've just combined the earlier loop into the later loop, which sounds fine. The problem is that these instruction emits set up branches to basic blocks that are in the future that we haven't initialized yet. That is probably what this is, but we'll verify. Well, oh, okay. Yeah, so here we're creating a branch to block sub instruction index +1. Oh, wait, this is in our own loop. Never mind. But it's a similar problem. Like the instructions themselves are going to do this. We just hit it here first because our loop does it first. Okay, this one's easy. This one's just saying this comment is weird. The array bounds check comment is weird, but the actual rule is, look, if it's an empty basic block, or if it doesn't have a terminator, just make it go to the next one, right? We can move that. I think we just take this out right now and deal. Oh, except that we need it. Okay. Here's what we do. We're just going to say, if we outputted a block without a terminator, which probably means an empty basic block, add a jump to the next one. Okay, so here's what we're going to do. If we create a block, we're going to set the previous block. And actually, then this can also do the branch for the entry block. I guess. I don't know about the set current debug location problem. I think that's probably fine. Let's see. Yeah, here's what we're going to do. We're going to say, anytime we make a block, we're going to ask about the previous block. So if previous block, we're going to do some stuff. We're going to make current block is this. Okay. If previous block, this is equal to current block, and so is previous block. I'll use null pointer since this is so modern here. So modern. Okay. And then all of this, this doesn't matter. We just say if the previous block didn't have a terminator, we create a branch to current block, right? Okay. So that gets rid of that crash. It's not going to, we're just going to crash inside one of the instructions now, but that's fine. That's progress. Yeah. So now we're crashing here. When we're trying to do bytecode jump, we're doing the same thing. We're saying blocks in the future and create a branch to that. And you can't branch to the future. Okay. How's it going, chat? Everyone's bored by LLVM. The number of viewers is dropping precipitously. Or maybe the Europe people are going to bed. So that's really, if you want to do a hot programming stream with the most viewers, morning to noontime Pacific is a lot of viewers' time. Branching to the future sounds dangerous. It does. Okay. So now what we want to do is after we create, we're going to have an option when we create an instruction. To make a target block. And we'll deal with that. So we're going to say make successor block, and we're going to replace all of these. Okay, so this thing is going to say make successor block what do we need to pass it? Well, probably a bunch of stuff. IR builder jump successor. Right? Okay, so what does that do? Make successor block. We'll call it create. Keep the terminology in line. And we spelled create with an E. Create successor block. LLVM helper. I don't understand why IR builder is a separate variable that's being passed. We need to fix that. Okay, return new block. Okay. New block is basic block create. Oh, what's module? There. Description. Function, right? Helper arrow function, probably. Ugh, no. We'll just pass that in. Parent. And then this is the insert before the last argument, right? Which I think we can eliminate. Like, I think yeah. No, we'll just elide that. I think it just drops. So we make the block. Okay. actually successor block, we should be able to say get insert block, get parent, right? Yeah. Why is this capital G and this is lower? Is that wrong? I don't know. We'll find out. IR Builder. How do you spell that? IR Builder. It's like this, and it's like that for some reason. Okay. Now, this is a disaster, but we're going to use it everywhere and try to make it work. We need to say helper successor block is new block, and we need to go there and say that this is that this is there. Now, everywhere we did this other thing, create successor block helper IR builder successor of string is equal. Okay. So I don't have to edit code, I'll just do that. Successor of cast bounds check. Array bounds check. Okay. Who else subscripts blocks? This is lexical blocks, which is a different array. That's what we're doing. Okay, I think we got them all somehow. Oh, so let's make this entry block thing be here, and that should add our terminator. Unless okay. Oh, wait. Create return? Create ret void. I don't know, something like that. Okay. So when we have a successor block up here, combine with, we want to rename the block if we had a debug name. If this also happens to be the top of one of our basic blocks. Okay, that can happen later. It'll run fine without that. Okay, so this sets current block. This is going to say if we want to create a new block or we have a helper successor block. Okay. It's probably terrible. Enterprise software is not going to write itself tomorrow. Yes. All right, let's just see if we crash. We do. Oh, did I miss one? What's going on? True block, false block. False block. Okay. What did I do? False block. That's a basic block. Is true block not set? Oh, this is in the future. Fudge. So if we're branching to one of our own basic blocks, we could be jumping into the future. Okay. I mean, we can create all of these ahead of time. So we could either, okay, we could try to get LLVM to go back and patch this later, which sounds like a nightmare. I don't think LLVM is made that way. You need replaceable type, and there should be a method called something like replace all uses with. Is that a thing? We could look at that to see if that's a thing. Alternately, we can create all of these. The problem is our insert befores are then going to have to change. But that's not that bad since we only have a couple of basic block creates now. Because we don't want to insert everything at the end of the function, right? Like if we pre-created a bunch of these basic blocks, we want to insert things before lay next. Yeah, it's doable. Oh, he was answering your question. Okay. It's always nice to have people who know something about LLVM because, like, damn, dude, it's just so hard to know what to do. Okay, so we can put back the part of the previous loop. Not all of it. We can put back the part of the loop that does the following. This is going to be annoying. Okay. So we do this. Okay. This loop will get much simpler though. So we make the name. All right. So that whole array is just initted. Now that has to change what we do down here. We're not incrementing, oh, there's BB index. Okay. Okay. Now what do? Now, instead of saying create block, we say next block. Okay, because those guys are making successor, I'm smoking crack. We don't need any of this stuff because those guys are making successor blocks, which means we don't need previous. Okay. So here's what we say is we say equals this thing I'm actually going to be all C++ and use a plus plus. Okay, there we go. That's great. Now, as we're in here, we will use it. And then at the bottom, we'll just say, we don't have one. So now the problem is we could have a successor block and a new basic block. At the same time. Actually, yeah, no, this is good. Just up here, we say, hey, we've got a new basic block. Branch to it from the previous block and set the previous block. Like literally up here. What is Emacs doing? I have no idea. Okay, here we go. We want previous block to be in helper, because when we make successor block, we want to set that to be previous block. Hold on. I don't know why LLVM is such a pain in the ass, but it is. So, I mean, I'm sure there's better ways to do it that I could do if there were only documentation that existed. But basically what I'm going to do, so the problem is we want to lay out basic blocks in order, but we have to create them all first. There's no patching that I know how to do. So we're creating them first. First, we're creating the ones we definitely know that we need. And then we're letting the instructions create their own. And so I think when the instructions create a basic block, they're going to have to do a thing that says previous block branch in order to keep LLVM happy. Or we could do that in post, but I'd rather not do that yet. Let's try it this way. So we are going to just have a function that says link previous block helper IR builder here. Is IR builder literally not? It's literally not on helper. Like, why? Okay. Anyway, so we link the previous block there. That's going to do this. We'll ignore this for a second. Okay. Then we go over all the instructions. And we don't need to do anything here. We don't need any of this. And we don't need any of this. I mean, GG's, it all goes away, right? And then here, actually, and this is redundant because this will be the insert block. So this all should be fine. Okay, we're going to come out of this with way less code. We're going to make some gains here. It's going to be good. Okay, so I think I just need to write link previous block and then use it. Okay, and then link previous block is going to do this following thing. This is going to be a little bit of redundant computation because we're setting it to null and then whatever, but okay. So we're just going to get it out of there. If it doesn't have a terminator, next block, and next block is this. Okay. There we go. So now I need to make sure that everyone either calls create successor block or link previous block. Let me just search for basic block create. People do still call basic block create, but if you call it after create successor block, we're okay. Create successor block, create successor block. And then, yeah. Okay. Let's just delete a lot of code. Maybe I'm stupid and something is horribly wrong. Even this set insert point stuff. Like, this shouldn't really go here. So first of all, we're not even writing these things into the blocks array. So there's that. And then anyone who sets up a successor block needs to set the insert point to that. So I think this is it. This is our new main loop. Something like this. It is tremendously better than the old main loop, like by an order of magnitude, which is great. Hopefully I didn't screw something up so badly that I need to make it horrible. All right, let's see how we crash. 93% chance that we crash. We aborted. Promote mem to reg. Okay, so this is some way in which it's unhappy. So we probably don't have a terminator or something. So let's do this. LVM sucks at finding and fixing errors, guys. All right. What is happening to our standard out? Oh, let's do no jobs. Lol. Here, let's clear. Clear! See, we don't actually really need to dump the function, I don't think, but sorry, I'm answering a text message. Okay. So BB2 from Star Wars is here. It's got a branch, jump successor. Okay. So we have an empty basic block at the end. And LLVM is a poop head. And our entry block as well. Okay, so we need to set our entry block. That's one flaw in the plan, is our entry block needs to be, this needs to be helper previous block. And then our final block, our jump successor. Ooh, this is rough because I guess we could do a ret void here. Wait, why doesn't this do that? Oh, it's the insert. Okay. So I think we put a ret void there, but then, all right, hold on. We'll cut and paste this. I should just rename this to paste because it's short and easier to type. Actually, clear. Clear, not King Lear. Assertion failed. LLVM converter line 4487. Okay, wait. Why does jump successor? We didn't. Jump successor didn't do anything. We say create successor block. Oh no, guys, this is. This is actually bad. Okay, first of all, we're not setting insert. Wait. Okay, the thing I did about inserting the branches is like not actually good. Because it's going to screw up right here. Like, we don't want to jump around. I mean, I guess we only do that. Okay, so one problem here. You know, we could actually do the thing where we store these in an array, right? We store all basic blocks in an array. That actually might be the best for my sanity. Then we could look at it. Set insert point to prev block. Oh, you're right. You're right. But I don't think that solves this other problem. I'm not sure that this actually can happen. Okay, so one problem is we don't actually set the insert point here. That's a mistake. You're supposed to... Oh, we're never doing that. All right. Okay. Okay, when we create a successor block from one of these, like the thing is we're creating the block ahead of time. So we don't actually want to branch from anything to it. Like we want to leave the insert point where it is. When do we call link previous block apart from this? When we get to a new basic block naturally. Now, if we create a successor block without having done that, that's fine because those instructions actually cap the block. Like there's always jumps and stuff. So I think this is actually the right thing to do. We link previous block. Actually, we don't even need this, dude. We're so sleek. We're so on fleek. still not going to be right. Clear. But we'll see. All right. What did we do now? We should actually, we went from BB0 to BB1, and in that case, we didn't set the jump. So, like that. Yeah, I think that's okay. Clear. Entry block. BB0. 69. Why is it called 69, dudes? $96. Okay, actually, I don't. Oh, 96 is the problem. See, 69 is fine. Oh no, 69 and 96 don't. So 69 does a call. Okay. I guess we have to jump. Right, because array bounds check doesn't make a jump to its successor, which it needs to. All right, I get it. I get it. Same with cast bounds check. You can't just fall through. So here we always branch to the next block anyway. We'll keep those even though we could factor these out. We're not gonna. Oh no, because we would have to call because we're doing both. Okay, never mind. Here there's a branch. Here there's a branch. That's it. So here we have strings are equal. That's what we were looking at. Here we have cast bounds, array bounds. What about jump one? Oh, jump one and jump two don't do that, right? Right. I feel like we're still missing some because there were like 8 cases in the original thing. It's going longer. Debug build LLVM. Writing own compiler. This is so 1970s. Well, I'm sure you in your modern programming wisdom can really teach me about computers. Well, I think we did it, guys. This is tremendously better than the old loop. And we made gains. Oh my gosh. This is so much better. Okay. Yeah, I suspect this doesn't do anything even. Let's see. Oh, let's not do no jobs. That just makes it slower. Is there a reason for not giving names to LLVM values that make it easier to debug the output? Well, part of that is probably I didn't write this code originally, and part of it is I haven't spent that much time working on this code now, so I've hardly ever dumped anything. Like I've hardly ever dumped any LLVM bit code and looked at it, right? For those cases, I didn't need to know variables, right? But if I was trying to like look at this and figure out what the hell was going on in the variables, I probably would name them if I knew how to do that, which I don't offhand. Uh-oh, I screwed it up. Wait, what? Hold on. How did that not complain then? Yeah, the 70s is really underrated. 70s was good. 80s things started kind of going downhill. Oh no. Wait, guys. Okay, hold on. Does it need no jobs for some reason? That would scare me. Also, I'm from the 1970s, so you know. Did I just delete something important? Accident? I think I just deleted a comment. What does no jobs do? It turns off most threading in the compiler. Nope. What did I just do? Did I not just run the game and it ran? Or maybe it failed to compile and I didn't notice and then I cleared. All right, let's build it again and we'll try to see why it crashes. Thought I ran it though. I removed that other no check-in, but then I put it back, didn't I? I believe so. All right, so this is going to crash. Why is it crashing? Oh, is it infinite looping? Is it like jumping to the same location nonstop? Application is in break mode. All threads were executing external code. Wait for work via worker factory. Those worker factories really are working. Okay. Wait, this is fishy because this is sort of what we were working on. Question mark. Did I put a bad jump in? This is very weird. The reason it's very weird is because these ifs are static, so there's no real control flow in this function. This is just a flat function. Wait, now it's fine. What? Never mind. I don't understand why that breakpoint was not firing, but we might have messed up debug info in some way. It's possible. Okay. What the hell is going on? Array resize? How is an array resize setting? Okay. So we have a faulty jump. I bet it's the array reserve. Yeah. So array reserve at least has an if statement in it. So Wait, we don't. Where's the return? I guess it's there. Okay, that's fine. Okay. Array.allocator will be equal to 0. So we will do this jump. Condex.allocator is not null. So we set our allocator data. Uh-oh, why are we in the else clause? Wait, what? I'm confused by what just happened there. That could be what's wrong. But it's the realloc that screws us. Officially, hold on. Let's do this again. Okay. Here, we assign these things. And we jump to (507H), which is another jump to here. Okay, that seems fine. Okay. What about the realloc? Allocator is going to be an array thing. That's probably what hoses us. Yep. We're getting there. Let's run it back. Uh-oh. Here we are calling into well, yeah. That seems very bad. Great. This reminds me, we still have to get the malloc out. These are still in the runtime library. Wait, but realloc takes 4 arguments. What the hell is this? Is our... Hold on. So according to this, realloc takes a void pointer, 2 S64s, and a function pointer. Wait, this is our... Oh, this is our realloc. Never mind. Okay, we do some stuff. We jump down here. That was array bounds check. Why was there an array bounds check? What are we even looking at here? Oh, cast bounds check. Never mind. Yeah, okay, that's fine. That's fine. We load A. So we're going to call realloc, and that's probably what hoses us. Look at these addresses: 7FF, 7F70, 7FF, 7F70, whatever. Okay. So if we try to step over this, no, that's not what hoses us. Okay. Did that dink with our stack pointer? It's returning that hoses us. Oh, is that my ret void? Guys, that's my ret. Yes. Yes. Or something. Probably one of these inserted returns that we are doing is very bad. Okay, before the call. I forget where the return address is. Where's the return address on the stack? Is it minus because you expect the callee to move the stack? Oh, right. It doesn't. Okay, never mind. It gets pushed on by the call instruction. I'm a dummy. All right. Stack here is 1189 OFF OFO. It is back where we expect it, so that wasn't bad. So what do I do? What is the problem? I feel like we're just going to dump it. Clear. It's a log function, I guess. So jump successor 4 goes to BB6. Why? Why is that happening? We're doing a return void there, which is bullshit. Yeah, we're returning void. This is not a void function. Ah. How many Doge coins do I have? I have 0 Doge coins. Why are we ret voiding? Oh. It could be this bullshit. No, it's not. This is not a C call. It's calling a C call. I hope that's not confusing something. Wait. Oh, we always ret void. Okay. Because we're returning everything as out parameters, I guess. Okay. Maybe it would be faster to look at the VOD and go figure out what I changed. I swear this ran. And if it's something really dumb, then yeah. I'm just not sure how this happens. Because this should not have any passes on it, right? This is just this should be just what we outputted. So how did we output a jump to BB6? BB6 must be the default case. This must be a switch statement thing. I don't know why we have so many. I am so confused. Guys, how is there this much frickin' bit code? Entry block, okay, whatever. I didn't mess that up. There's a trillion gaps. Who generated this? I'm gonna die from peanut butter M&Ms, guys. Oh, you know what? You know what's wrong? Remember when I said we have to do all the insert point stuff correctly? We didn't do that. I'm actually not sure if that matters. But like our functions are coming out all scrambled because we're making all the basic blocks first for the front end basic blocks. And then we're making the filler ones later. And those are all at the end. So when we make a successor block, we can say helper insert before, right? I forgot that part. Okay, oh guys, I'm having a sugar rush from too many M&Ms. Too many M&Ms. Is it theoretically possible to piece together the whole compiler from looking at the stream? I don't think so. No. Okay. One M&M, one pull-up. Let me go do a few pull-ups. I'll be back in a second. I went for chin-ups because that's how you got to do it. All right. Well, I already did pull-ups this morning, so this time I did just shy of 7 chin-ups, which is not great. We're getting there though. Also, I have a lot of water, oranges, and M&Ms in my stomach, which I'm sure is weighing me down. All right. So, wait, this previous block is the insert before. Wait, no. No. I almost got burned by incrementing BB index. Never do that. All right, so this part is growing a little bit, but maybe we can make it a little bit less gross. So we have this insert before. I don't understand what these debugger basic blocks are. Anyway. Okay, I feel like that actually shouldn't impact the code generation. Okay, this makes more sense though. We don't have weird jumps going back. Now we have a return. We have, whenever we outputted an empty block, we just jump to the next one. We actually could also elide the empty successors if we want to. We could detect that that there's a basic block on the very next instruction. But let's not worry about that yet. Because we do seem to do that a lot. Yeah. All right, so let's take out that assertion. Let's see if that fixed. I sort of feel like that didn't fix any code gen, but I'm not sure about it. I'm not sure about it. Same thing. Yep, same problem. Maybe we'd be able to step through it more intelligently now. Okay, here we did a return and then a branch. That seems weird. Whoops. That might be screwing LLVM up. We're putting returns and then branches after. Oh, I think... Oh, return... That's what was wrong. Remember when I said, hey, I feel like more of these instructions need basic blocks? We need to make successor blocks in more cases than we're making. Okay. The original list, now, as I recall, included return. I have an old copy of the code here. It was return, jump, jump if1, jump if2, array bounds check, cast bounds check, and strings are equal. We're not doing it on return. I know we're doing it on the bounds checks and the jump. Let's check them all. So on jump, we create branch. I guess we need to make a successor block. Okay. Let's call it next block. All right. And then, so return, how about strings are equal? I'm pretty sure we got this one, right? Yeah. Okay. Return, however, needs this. Successor of return. Like that. Actually, let's go through this part. Let's actually just dump and not assert. So we can see what that looks like without killing our compile. Clip of seemingly working to non-working.
Compiler, this is so 1970s.
Well, I'm sure you, in your modern programming wisdom, can really teach me about computers. Yeah, that ran. Well, I think we did it, guys. This is tremendously better than the old loop. And we made gains. Oh my gosh. So that was deleting a comment. So much better. Okay. Yeah, I suspect this doesn't do anything even. And then we brought that back. I think it didn't compile correctly. Oh, let's not do no jobs. That just makes it slower. Right, and here's where it starts failing. I think Visual Studio didn't compile everything.
1970s.
Well, I'm sure you, in your modern programming wisdom, can really teach me about computers. Oh, that was the end of the clip. Okay. Yeah, but we didn't really change anything there. I think that was a compile fail. Actually, hold on. Can I tell, whoops. Can I tell from the beginning?
Own compiler, this is so 1970s.
Well, I'm sure you... So the problem is, we don't show me rebuilding here. But like it wouldn't have worked. Guys, I don't understand. It does not make sense. Okay. So these blocks with no predecessors may make LLVM angry. So this is happening because... Wait, why are we getting a jump successor, a successor of return, and a... What? Now I'm really confused. How the insert before is not working in the way that I expect. Oh, wait, it's going... What? Jump successor 2. I can't. Okay, hold on. Where do I get my ideas from? The idea farm. You grow the ideas on the idea farm. All right. Okay. So we have jump successor with no predecessors. Okay, so first of all, entry block is skipping this. But secondly, what? I don't understand something about the LLVM insert before. These are just coming out in a seemingly totally effed up order. Okay, what's going on? This would be so much easier if we could just make the blocks and then patch them like any reasonable system would let you do. And maybe it does let you do, but there's no documentation. So screw you guys. So where does jump successor get made? We branch to jump successor 1 there. But then who creates 58? That's just it being... Wait, literally nobody jumps to jump successor. Which I guess makes sense. So the real problem is who is creating 54? Also, why can't I get LLVM to just create the basic blocks? Like, isn't that pretty easy? Is there a way to, can I just output a bunch of things and just say make the basic blocks, please? Anyway. So all of these jump successors, like why do we have a return successor followed by a jump successor? That is what is driving me nuts. It's probably this one. Let's make the... Let's just take that out for a second and figure out what's going on with less noise. But we have a no check-in because we haven't figured out what is going on. Okay, 3154. Why aren't these... Oh, no, we don't have our... Okay, we got to go to debug build because we don't have our basic block names because we're not building in debug build. I could temporarily... we'll just leave it. I could change it. We'll just leave it. Debug. Basic block create, set insert point. This gives you full control. That's what I'm using, dude. It sucks. All right. Write your own backend. This gives you full control. That is correct. It does. It does give you full control. Okay, so now we've got our BB zeros and stuff. So that makes more sense to me. So we have BB0 goes to BB1, goes to BB3, or jump if successor, which matches to BB2. Now what we could do is just combine these blocks instead. Instead of making a new block, we could use it. Wait, I thought we were doing that. Oh, we're probably doing that right after the link or something. BB2, cast bounds check fail, return, successor of return, Go to BB9. What? Why is successor of return going to BB9? Actually, we don't. Okay, the return is redundant. We actually don't need a successor of return because any instruction after a return instruction has to be a branch target due to the front end. Interesting. Okay, hold on. Okay, same with a jump. So then, to the extent that we have weird things happening, I just rolled back about 20 minutes in what we're doing. So now if we have weird stuff happening, it's probably because I'm doing extra weirds. Right, so return and jump redundantly. Yes, I understand. Okay. Okay, we go to BB1, BB3, jump if successor goes to BB2. That's a waste block, but that's fine. Supposedly, BB2 goes to 59. Oh no, if I1 59, go to successor of cast bounds check or cast bounds check fail. That's fine. Here. This is a little bit silly, but it's fine. Okay, successor of cast bounds check. Great. Okay, we have a return. Where does this branch to BB9 come from? What is this debug number, the 10453? What does that mean? Is that the instruction index? No, it's the... There must be some number that we're setting intentionally. Anyway, why are we branching to BB9? We're only supposed to be doing that if there's no terminator. Does return count as a terminator? It should. Right? Why are all these ret voids going to BB9? Did I do that accidentally? Create ret void and then don't. Okay. I don't get it. I don't get it. Where is this coming from? What is this debug number? Is this something Josh put on? What does it mean? Can I put something else on? Like where, like what freaking line generated this? So I could set a debug flag. I am so much happier with this loop. Okay, so first of all, is this a problem? Secondly, so first of all, where are those instructions coming from? We didn't actually used to have them. Secondly, is it crashing us? Yes. Is it crashing us because those are illegal in some way? Or is it crashing us for other dumb reasons? I have no idea. I don't think it should matter. A ret followed by a jump to another ret does not seem like it should matter. That branch used to be in successor of return. No, because that might have been our empty block branch thing, right? Link previous block puts a branch at the end. But I don't think it's that, because the only ever times we do that, we then cycle out the previous block. But we had a lot of guys going to BB9. Do I have the insert before order and stuff correct? It's the fourth, parent is third. I hope that's right. Oh boy, it's our favorite documentation. All right, create. Parent insert before, yes, okay. Very good. Wait, why don't I just do split basic block? Oh, because I need to branch target it usually. Must have a terminator. Okay, who cares then? God, this makes me angry. Okay. 2 terminators are illegal. Yes. So how do I know when this is happening? I could just step through. I could set a debug flag and just, like when we're doing this particular function, right? And I could just step through like BB0 doesn't have it, BB1, BB2. Okay. Successor of cast bounds check. So what I could do is I could step through it up to cast bounds check. And then we output all. Did I mess up link basic block? If instead of linking to this, I link to the end. I don't know. Link previous block. To next block. Next block is the argument. Insert before only gets used when we make a successor block. And only gets set there. Okay. Yeah, I think that's the plan is we go to BB2. In fact, we can dump this routine, right? Okay. Oh boy. We've got it all mixed up. Oh no, we just changed the output. Never mind. It just looks spammy. Okay, basic block 2 has these things. Cast check, blah, 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 jump. Wait, it's got a return followed by a jump in our basic block that we are outputting. I guess that's illegal, but is LLVM going to really care? Why are we saying jump 9? Oh, because it's a switch statement. That's the remnant from the switch statement. Okay, it's no wonder I was confused about that because the LLVM backend code is not making that jump. Now, I could fix this probably. And that would help, actually. It would get our Weissman score down slightly. But also, it would help make the LLVM backend output more understandable. So it's probably a good idea to do that. Am I checking for a terminator in the jump IR generation? No, because the assumption is that the input is reasonable. I mean, again, we can always... I don't know. We could always put the... I mean, okay, here's the thing. My front-end code, you could always put multiple return statements in a row or whatever, and we're just going to output that. I don't think this is what's breaking us, though, because this is not what's breaking us, because we've been doing this for like weeks at least, or at least a week since we did the Weissman score. Like, I think I should maybe try to edit this because it'll help make things make more sense. But because in this particular case, this isn't typed by the user. So we could do that. And then we can put in the successors of return. Right, okay. It is not actually true what I put in the comments about the jump target. Okay, that's true as well. Like this thing that I put before return and jump, this is not actually true. We actually probably need to do this, I guess, technically, because LLVM sucks. So we're going to put those back. But we're also going to do this switch statement thing. Where is it? Emit switch. There we go. That's what I was looking for. So for every case, we do the body, and then we do the go-to after body, which okay, so if we actually generated a body, okay. We don't need a jump because we already did a continue, return, etc. So if there's an is unconditional branch, I know I got some things wrong. Okay. So return, jump. I think that's it. I don't actually know. All right. Go to after body source. Okay, I hope we didn't screw that up. Okay, what's instructions? I forgot part of it. Oh no. All right. So we do have a count. We just don't. Okay, we'll try this. Um, we only. Okay. Instructions dot. Last bucket. Okay. We try this on x64 first. Dang it. Was I false about this? Before 506, after 512. Was I wrong about my invariant? I was wrong about my invariant. This kind of sucks. Because we don't have a previous bucket. We could do that. We're probably going to want that. We're probably going to want that. Okay. So here, I'll keep that comment in case we want to make it true. All right. Dang it, I just modified my file. I really screwed that up. Guys, this is not going well. Oh boy, when you start doing stuff like this, it's kind of break time. Hold on. Is unconditional branch. Let's just say false for now. Does that fix all the problems? Yes. Oh, right, guys. We actually... The problem is... we could have a jump. So if you have nested if statements like inside a switch case, you end up in this thing where you're like, hey, I want to jump to the next instruction. Right? So we need an instruction there in that case. Let's kind of do this. I think if we always just check return. Like this is just supposed to be a short diversion before fixing the LLVM situation, but it's turning into more. It's turning into more. Let's see. It's still screwed up. What? Wait. Wait, are all those errors how bad did I hose the game now? So we still kind of load, but I don't like all those errors. So if I return false, do I get all those errors? If so, then there are consequences to doing this edit, and I don't want to think about them yet. Then, yeah, okay. There's something I don't understand going on with the switch statement arrangement that probably necessitates that branch to exist, and I will want to rethink about that, but I don't want to do it now because I'm in the middle of the LLVM thing. So okay. Well, rip that. Okay, we're just going back to LLVM. We're going to have the extra blocks. Let's make sure this still works. We're going to have the extra blocks. We're just going to do it and see. Wow, we've been streaming for 5 hours. Feeling a little tired. I would so like to get this figured out. Okay, so now we're making a block. We have no predecessor dead code, which is technically illegal, but maybe it's fine. This is still going to crash. Wait, what? Did we actually fix it? I didn't expect that to fix anything, but perhaps it did. I just went back and put the successor blocks in again for return and jump. And maybe that just makes LLVM happy in a way that it wasn't happy. We have a lot of silly blocks. We can elide some of the silly blocks. Okay, it works now, guys. Yay. Oh boy, I'm tired. I mean, I guess that's good. So I'm going to put this here. I'm going to put on a piece of paper. Okay, I am actually very happy, despite the fact that I'm tired about searching this stupid thing for like a year. I am actually happy that we managed to delete so much stuff. So this main loop used to be hell. It used to be 2 loops, one of which was hell. And now it's 1 loop that is kind of reasonable. There's still a little bit more here than I would like, but we can work on that. Actually, there's one. We now do a loop here for the outer loop, just the BBs. That's actually fine though. That's only 1D loop. This is like our 2D loop that goes over every instruction. This is the 2D part. The second D part has very little in it. So this is good that most of this is up here. Okay. Now, let's scan for other no check-ins. Yeah, we don't need that. That is not true. Demonstrably not true. I feel like maybe this doesn't do anything. What if it was this that broke the game and like somehow Visual Studio wasn't doing it when I put it back? Like what? Maybe I'm going to baby rage if the game doesn't work. Game works. Game works fine. I don't know what you're talking about. All right. This is great. We have much higher quality LLVM loop. Way better. I like this so much better, guys. All right. Took longer than I wanted to at the end there. Let's run tests in release mode. We like release mode. When you run the debug compiler, it takes longer than the release compiler. That is true for software everywhere in the universe. The purpose of a debug build is to be slower and more debuggable. Uh-oh. We gotta fail, bros. Let's try putting this back for a second. Although I feel like that's something LLVM would have told us about. Nope. Calling conventions. All right, well, I'm going to take a break. We're mostly working. There's something we are not handling correctly. Let me just, okay, while I've got this open again. What needed a successor block? Return jumps, array bounds check, cast bounds check, strings are equal. We did put all of those. So, I don't know. The fact that it's calling convention makes me think it's something about returns. But I'm going to take a break. I am not going to subject myself to LLVM anymore. I'm going to take a break. I'm going to relax. I'm going to read a little bit, and then maybe we'll be back tonight and do some gaming. Maybe we will do some more programming. I don't know. Okay, now let's find someone to raid. Pet Ducks Ultimate Hacking Championship. I don't see anything. Does anyone have ideas? Zorchenheimer. Who is Zorchenheimer? Nobody on this stream is named. Wait. Why is searching on a web page so horrible? Where is this substring? I don't see anything. All right, great. Zorchenheimer. Okay, oh, it's there. Making trees. And go in 6502.
Use more pizza technology so as a signal.
He's got Hacker Man. All right. Since he's got Hacker Man, we could rate him. All right, so thanks everyone. And I'll see you later.